The last part of the notes is going to talk about phase changes. And again, when we're going from a solid to a liquid or a gas or back down again, we have, melting and freezing. They occur at the same temperature. We have vaporization and we have condensation. This is going one way, this is going the other way. And then sometimes we can go from a solid to a gas or a gas to a solid. If you've ever played with carbon dioxide and Halloween time, you got that, that big gas coming out, because it'll go from a solid to a gas. It won't be a liquid in between. So that's sublimation. And if you go from a gas to a solid, that's called deposition. Okay. So these are the different phase changes, and you can see exothermic is a process where energy is released, and endothermic is where it's absorbed. So when you melt stuff, when it goes from a solid to a liquid, you have to absorb energy. So that would be melting, that would be endothermic. The same when you boil off water. You have to add energy. It has to absorb energy in its system for it to change from a liquid to a gas. So you can see the differences in here between the endothermic and the exothermic process. Okay, so when you convert from one state of matter to another, it's called a phase change. And you can actually calculate the energy needed, and we're going to do that after these notes. I'll show you how to do that. Okay, so energy either has to be added or released. If it's added, it's endothermic. If it's released, it's exothermic. Because again, remember, endothermic absorbs into the system. Exothermic, it releases it out into the surroundings. Okay, and here's our phase changes I already went through. We have melting and freezing occurs at the same temperature, vaporization and condensation, and then you have these two, sublimation and deposition. Those are where you go from a solid to a gas or a gas to a solid. Okay, those don't happen with every substance, but these do. Okay, so whenever there's an energy change, okay, when you change your state, if you go from a solid to a liquid, there's going to be a change in energy. And if you melt something, it's called the heat of fusion, okay? It's the energy required to change a solid at its melting point to a liquid. And again, I'm going to show you how to calculate that. Here's some numbers here, but I'll show you this after after the notes. I'll show you how you can actually calculate the energy needed, okay? Heat of vaporization is the energy it takes to change something from a liquid to a gas, okay? So when you're doing these energy changes, we're going to use specific heat like we did before for the temperature change, and then when we get to the phase change, we're going to use heat of fusion if it's melting, or we're going to use heat of vaporization if it's boiling, okay? And again, there's also heat of sublimation, and that's the energy required to change a solid directly to a gas. Not real common because not very many substances go through sublimation. Okay, here's a heating curve, and you can see you start at a certain temperature, and then you notice the flat parts. Those are phase changes. Okay, all the energy that you're adding at that point is changing it from, in this case, from a solid to a liquid, and in this case, from a liquid to a gas. And obviously, it's going to take more energy to change it from a liquid to a gas than it is here. So that's why they're not as flat. Okay, but this would be a heating curve. And actually, if we had labs, you guys would have done one of these. I have an activity where you're going to kind of do it, but I'm sorry, because we can't go in the lab, you won't actually get the temperatures. Okay, but this is what a heating curve would look like. Okay, within a phase, okay, this is a phase change. Okay, so the temperature doesn't change during a phase change. Okay, all the energy that you're adding is going to finish changing it from a solid to a liquid, or from a liquid to a gas. But first you heat it up, you get it from minus 25 to 0. Now you got a phase change. Now you're going to go from 0 to 100. You got to heat it up, and now you're going to have a phase change. Okay, so that's how a heating curve works. Okay, for a phase change, the product of the mass or the moles, you're going to actually use that heat of fusion or vaporization, and then you have to multiply by the mass. And again, I'll show you how to do all this when we're done with this. But you can actually calculate the energy it takes from here to here. Okay, you're going to have to do a calculation here, one here, one here, one here, and one here. And again, I'll show you how to do that. It's not as hard as it sounds. Okay, now if you add vapor pressure, if you increase the pressure on it, then things change. It changes the temperature. If you increase the pressure, then things boil at a higher temperature. It's kind of if you have anybody that cans things and they put them in a pressure cooker, because it increases the pressure, then they boil at a higher temperature, and that boils off all the germs and stuff, and then they seal. So if you increase the pressure, then things will boil at a higher temperature, okay? So the temperature rises, and again, that's the process behind canning, okay? You use that pressure cooker and you put your things in there and you boil it. It's going to be actually a higher temperature than normal, and that's why it cooks off all the critters, so there's no problem. You're not going to get sick after you get done canning your beans or whatever it is, okay? So vapor pressure, what it does is as the molecules escape the liquid, the pressure exerts more force, and then again, it doesn't have to be normal temperature. I mean, it'll boil at a higher temperature. Okay. For example, we're a little below sea level, or above sea level, sorry. Water boils for us about 97, 98. Okay, put it in a vapor pressure, now it's going to boil like at 110. Okay, that's what you need to take care of those bugs, to kill them off. Okay, so again, vapor pressure increases the boiling points, or decreases the boiling point. Sorry about that. They boil at a higher temperature. That's what I should say. Okay. And here's what happens. You can see the vapor pressure. Here's water. Here's where it normally boils, but you can get it to boil at a higher temperature by increasing the pressure. Okay. So boiling point of a liquid is the temperature which the vapor pressure equals atmospheric pressure. This is normal. Okay. Diethyl ether. You got to like that name, right? And you can see there's a variance of them, but their curves are very similar. Except for ethylene glycol, this is antifreeze. We would want this to be a real low curve, right? Because you're putting that in your car in hopes that it stabilizes. It can get really hot and really cold, and it's not going to affect it. So we definitely want this guy down here, okay? So normal boiling point is the temperature which vapor pressure is 760 torr. If you remember, 760 torr is 1 atmosphere. It is 101 point whatever kilopascals, but that's one standard right there, okay? So again, here's our phase diagram. They have triple points, and they have, you can see melting and freezing and all that. But again, if you just measure your temperature, the other one I showed you where you have your phase changes, you can calculate the temperatures at what all this stuff happens. And when we're talking about supercritical and all that, that's when you mess with the pressure. Okay? So when you start messing with the pressure, then you change all those numbers. Okay? And again, that's what a pressure cooker and all those things do. Okay, so it changes the state, and then they have what they call a triple point where it can go either way. Here we have a solid, liquid, and a gas at this point. And again, dealing with the pressure. Okay, here's water, again, with it increasing the pressure. Okay, and again, that's something that it changes the forces in the liquids. If you remember, we talked about van der Waals forces. Those would be London dispersion forces and the dipoles. Okay, because you're causing those forces to be stronger, then you're changing the temperatures at which things freeze and boil and all that. Okay. Water is unique. You know, the most unique thing about water, again, we talked about, is that it's less dense as a solid, which is really important, you know. But the slope of a melting curve is negative as pressure is increased. So that you can actually, the melting point decreases as you increase pressure. That's different with water, but again, water's kind of a different substance. Here's one for carbon dioxide. And again, remember, carbon dioxide is one of those substances that goes from a solid to a gas. It's really tough to get carbon dioxide to be a liquid, okay? Cannot exist in the liquid state if the pressure is, you know, below this. So it has to be. That's, again, why it goes through sublimation. It's really cool at Halloween time, right? You put it in your punch, and then you get this fog going on. That's because as soon as it warms up, it won't become a liquid. It'll become a gas. Okay. Here's showing you some crystals. And again, some substances go directly to the solid state. We talked about that. These guys go through deposition. Okay, it happens sometimes under certain conditions, and again, it's not all substances. It's actually very few substances. So substances that do not go directly from solid state to liquid state, they go from solid to a gas, or vice versa. Okay, here they're showing you, this is, it doesn't even say what it is. One common substance that does that goes from gas to a liquid would be borax. If you guys have ever put little crystals on your pipe cleaners for decorations and all that, okay? But not very many substances do that, so I'm not going to spend a lot of time. I'd rather talk about the common substances than the weird ones. You know, we don't want to talk about the weird ones. But anyway, so when we're talking about phase changes, you can actually calculate all the temperatures that, you know, all the energy that it takes to go from the beginning to the end. And again, I'm going to show you that in one of my hand videos, okay? And so that'll be right after this. So as of right now, we're done with chapter 11.